Guys, welcome back. So we are going to be starting the next part of chemical reactions, and we're going to be talking about types of reactions. Now, I hope you enjoyed the video on the foldable where I showed you how to build the foldable. This will help you be able to better identify the reaction types, okay? So we're going to be talking in this chapter about 5 different types of reactions, okay? There are more, but we're only going to talk about 5. We will be able to predict the products. Now, at first, all we're going to be doing is looking at the reactions and trying to identify them. Following that, in a later video, we're going to talk about how do we predict the products if we know the reactants, if we know what type of reaction it is. It'll allow us to be able to predict what's going to form on the product side, okay? Now, for some, we will be able to predict whether they will happen at all, okay? And then we will also recognize them by the reactants. Okay? So I'm going to show you a quick video clip of some types of reactions here.
There are 5 major classes of chemical reactions. A synthesis reaction occurs when 2 or more substances combine to form a single product. When copper is placed in hot sulfur vapors, copper 2 sulfide is produced. In a decomposition reaction, a compound breaks down into 2 or more simpler substances. When calcium hydroxide is heated, calcium oxide and water vapor are produced. A single displacement reaction occurs when one element takes the place of another in a compound. A heated mixture of powdered iron 3 oxide and powdered aluminum produces molten iron and aluminum oxide. This is called the Thermit reaction. In a double displacement reaction, the positive and negative portions of 2 ionic compounds interchange. Mixing potassium iodide and mercury 1 nitrate produces insoluble mercury 1 iodide. Centrifuging removes the precipitate, leaving potassium nitrate in solution. The solution can be checked for potassium using a flame test. A combustion reaction occurs when a substance rapidly combines with oxygen to form 1 or more oxides and releases energy. Methane mixed with oxygen readily reacts when a spark is provided.
Alright, so this is just an example of some of the types of reactions that you will see in the lab that we're going to do later on. Not this week, but next week. Okay? Now, first type of reaction we're going to talk about is a synthesis reaction, also referred to as a combination reaction, okay? So basically you have 2 elements here that combine to form one compound. It's kind of like addition, like in math, when you add 2 numbers together and you get an answer. That's what a synthesis looks like, okay? Here's an example of sodium reacting with chlorine, forming sodium chloride, okay? Here's another example of calcium reacting with oxygen to form calcium oxide. Here's another one where you take sulfur trioxide, mix it with water, and you end up with sulfuric acid. So, we can predict the products if there are 2 elements. Okay? And then we can predict that's MgN. Okay, so here's a simulation of another type of reaction. Okay, what if we have hydrogen gas reacting with oxygen gas? It forms water. Okay? Now, in a decomposition reaction, it's actually opposite of a synthesis reaction, okay? So they start out as a compound and they split apart, okay? So one compound or reactant falls apart into 2 or more elements or compounds, kind of like when trash and stuff decomposes, right? It splits apart into its component elements. It usually requires energy, okay? So here you have your compound together and it splits up into A plus B. Alright, here's an example of splitting sodium chloride up into sodium and chlorine. It actually takes electricity to do that. And then calcium carbonate, you just saw a demo of that. We had to add heat to that reaction in order for that to decompose, okay? Alright, so you can predict the products if it is a binary compound. Binary meaning 2, right? So you can predict in a decomposition what it would split up into. When you have more than 2 elements, it becomes a little more complex than that. So, for example, H2O you add electricity to it, and you can decompose that into its component elements of hydrogen and oxygen gas. Mercury oxide, you can break that up into mercury plus oxygen by adding heat. Okay? Now, if the compound has more than 2 elements, you must be given one of the products. Okay? The other product will be from the missing pieces. So in this problem, we would have to give you one of the products. Okay? So if I gave you nickel, you can see that this would break up into carbon dioxide gas. Okay? And in this one, if I gave you H2, once again, it's going to break up into carbon dioxide gas. Okay? Now, in a single replacement reaction, that's kind of like when you have one thing and you like something else, so you drop that and go to the next thing. So only one thing is switching. Okay? It's also referred to as a single displacement. One element will replace the other element. Now, the same element cannot connect together. So if I have a metal on the left side, it can only replace another metal. If I have a non-metal, it can only replace another non-metal. Okay? So the reactants must be an element and a compound, and products will be a different element and a different compound. Okay? So here you have an example of A plus BC. Okay? If A and C switch places, we're left with B, right? So if we have sodium, okay, sodium's a metal, and you're mixing it with strontium chloride, strontium is also a metal. So strontium and sodium cannot connect together. You cannot put two metals together. So you have to be careful. Remember, when you look at a compound, the metal is always written first. So you need to identify what this is. If it's on the left side of the stair step, that means it's a metal. So it can only swap with another metal. So sodium and strontium will switch places on this side. So now you have strontium left with sodium chloride. Okay? Here's another example. Now this one, fluorine is on the right side of the periodic table. Okay, that means it's a non-metal. So fluorine can only switch with a non-metal, which is chlorine. So fluorine and chlorine will swap places. So over here you have lithium fluoride plus chlorine gas. Okay, we can tell whether a reaction will happen based on the reactants. Some are more active than other. The more active element replaces the less active element. Okay? Now, in a double replacement, that's going to look very similar to a single replacement, except you have compound-compound equals compound-compound. So I always tell everybody the first element of each compound switches partners on the right side. So from the left, they will switch partners and form new compounds on the right side. Okay? So two things replace each other. Reactants must be two ionic compounds or acids, usually in an aqueous solution, meaning dissolved in water. So most of these double displacement reactions occur, they must be in an aqueous solution or already dissolved in water in order for this to happen. Okay, so here's an example. You have AB plus CD, right? A and C are going to swap places. Okay, so you have AD now and CB. All right, the first element of each compound switches places. Okay, so here we have zinc sulfide plus HCl. So the Zn and the H are going to switch places so that when it's on this side, okay, I don't have my arrow there. There should be an arrow right here. It'll be Zn plus ZnCl plus H2S. This next one we have silver plus NaCl. So Ag and Na are going to switch places on the other side. And we have AgCl now and NaNO3. So you see how that happens? The first element of each compound swaps places. Okay? Now, you ever remember the show Wife Swap? Okay? That's kind of what like this is. Remember when they go and they live at somebody else's house and they swap homes for a while? That's kind of like what a double displacement reaction looks like. Okay? A reaction in which a gas, a solid precipitate, or a molecular compound is formed from the exchange of ions between two compounds. Okay? If both products are aqueous, then no reaction takes place. Okay? Now, last we have combustion reactions. Those are the ones that catch on fire. So remember that video I showed you a week ago? That's a combustion reaction. in a combustion reaction, a compound and oxygen burn, and it's usually a hydrocarbon. So it's usually a carbon and hydrogen mixed together. Whenever reacting with oxygen, will always produce the same products every single time. So that's what's nice about a combustion reaction, is you always know what it's going to form. Okay, so it's going to have a hydrocarbon, okay, and it's going to react with oxygen. So here's an example of a combustion reaction. Well, it's not playing. I don't know why it's not playing. Well, I'll fix that later. All right, so here's an example of a combustion reaction. You have methane gas reacting with oxygen, produces CO2 and water, and a lot of times after a combustion reaction, you'll see plus energy, meaning it gives off energy. Okay? Here's another one, C3H8, propane plus oxygen yields CO2 and water. And it's not liquid water, it's actually water vapor is what's formed. This one, benzene, okay? Benzene reacts with oxygen, creates CO2 and water. Okay? Charcoal used in a grill is basically carbon. The carbon reacts with oxygen to yield carbon dioxide. The chemical equation for this reaction is carbon plus oxygen yields CO2, which would be an example of a synthesis reaction. Okay? When will a reaction not take place? Okay? Less reactive metals cannot replace more reactive metals, so iron cannot replace magnesium. Okay? Less reactive halogens generally do not replace more reactive halogens. Okay? Bromine does not replace chlorine. And if all the products are soluble in solution, it will not precipitate and the reaction will not proceed. Okay? Now, how do you recognize which type? So we're going to skip redox because we're not actually going over that. But, okay, so element plus element, okay, element and compound, and compound and compound. And then on the one where you look at the products, that's a combustion, okay? All right, so let's look at some examples. So synthesis, decomposition, that's going to be compound and compound, so it's going to be a double. There's an element in a compound, so that's going to be a single, and then a decomposition because it's a singular compound. And then now you have a compound and an element, it's going to be another single replacement. Okay? Compound, compound, it's going to be a double replacement. Okay? All right? Single compound can only do one thing, right? It's going to split apart. So that's going to be a decomposition. All right? Compound element, doesn't matter what order it's written in, okay? Compound and element is going to be a single replacement. Then you have element plus element, okay? So it's only going to be one thing, which means it's going to add together and form a synthesis reaction. Okay? Compound element, all right? It's going to be a single replacement. And a compound is going to be a double replacement. Okay? All right. So, balancing equations, that's for next week. We're not going to talk about that today, and I hope you guys have a great weekend.